Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today, grid game, Leetcode 2017. In this problem, we are given a zero index 2D array grid of size 2 into n. That is, we have 2 rows and n columns, where grid RC represents a number of points at the position r, c on the matrix. Two robots are playing a game on this matrix. Both robots initially start at 0, 0 and want to reach the bottom right, that is 1, n minus 1 position. They have painted robot 1's path with red color and robot 2's path with blue color. Each robot may only move to the right, that is from r, c to r, c plus 1, or down, that is from r, c to r plus 1, c. At the start of the game, first robot moves from 0, 0 to 1, n minus 1, collecting all the points from the cells on its path. For all cells r, c traverse on the path, grid RC is then set to 0. For example, robot 1 went through this path, so we set all the cells on this path to 0. Then the second robot moves from 0, 0 to 1, n minus 1, collecting the points on its path. Note that their path may intersect with one another. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. If both the robots play optimally, return the number of points collected by the second robot. Then in example 1, part taken by first robot is shown in red color, so it collects the points 2, 5, 5, 1, leaving the points 4 and 1 for robot 2. And for the remaining points, robot 2 tries to maximize the points it can collect. It can either go this way, collecting 4 points, or it may go this way, collecting only 1 point. So it will choose this path, and the maximum number of points robot 2 can collect will be 4. Similarly, in example 2, robot 1 moves on this path and collects all the points so that it minimizes number of points for robot 2, resulting in total points of 4 again. And robot 2 can go on this path, collecting the maximum number of points, which is equal to 4. Now from these initial examples, it may look like robot 1 is trying to maximize its points. For example, in example 1 grid, it starts at 0, 0 and collect 2 points. Now it can go rightwards or downwards. On the right side, we have 5 points, and if it goes down, it will just get 1 point. So it greedily moves towards right, where it can get 5 points. Now again it can go forward, where it will get 4 points, or it can go down, where it will get 5 points. So it chooses to go down and collects 5 points. And then it has only one part to go, that is right. It collects 1 point from there. Similarly, in example 2, robot 1 starts at 0, 0. Then either it can go to right and collect 3 points, or it can go down collecting 8 points. So it collects 8 points over 3 points. So it greedily picks up 8. Then only path it can go is towards right, so it collects 5 and 2 points. So this gives the impression that if we maximize the points for robot 1, it will automatically minimize the points for robot 2. However, this is not the case. For example, consider this grid. And now suppose robot 1 tries to maximize its points. Then it can choose the path shown in red. So it will collect 1, 5, 5, 4, 1, collecting the maximum number of points. But in this case, robot 1 will collect the points shown in blue. That is 5 plus 5 plus 1, that is 11 points. However, the problem defines that robot 1 has to minimize the points robot 2 can maximize, right? So because of this, the correct path the robot 1 must choose is this one, such that at column 1, it would have gone down and chosen 13 points for itself. And in this case, robot 2 would have got just 9 points. And this is the minimum number of points robot 2 can collect if it plays optimally. So robot 1 cannot minimize the points for robot 2 by simply maximizing its own points. So now the question is, what should robot 1 do so that it minimizes the points for robot 2? For that, let's look at the naive approach. Robots start at 0, 0 and want to reach 1, n minus 1. And both the robots can either go downwards or rightwards. So given these movement constraints, how many paths can robot 1 take? It can take n paths, where n is number of columns. And these paths are either it can go like this, or it can go like this, or it can go like this, or it can go like this. And here, since n is equal to 4, we can take 4 possible paths. So each of these paths involves robot 1 going down at a specific column and then turning right, Let's call this column a pivot column. And suppose this was the path which robot 1 took. Then what are the number of points robot 2 can collect? Since robot 1 took this path, it collected all of these points. Now the points in all these cells is 0. So robot 2 has to choose between remaining points located in two sections. These sections will be either points on the top row to the right of the pivot column or points on the bottom row to the left of the pivot column. This is because suppose robot 2 tries to collect these points, it cannot move back to collect any previously missed points like the points in the bottom left section. Similarly, if robot 2 takes this path, then it will be collecting these points, but it cannot move up and collect these points. So robot 2 has to choose between remaining points either in the top right section or bottom left section of the pivot column. Now let's denote some of the points in the top right section as top sum and some of points on this bottom left section as bottom sum. Now of these two paths, robot 2 will choose the path which accrues maximum number of points from these two options. That is, we will take maximum of top sum and bottom sum. So to summarize, we need to evaluate all possible paths that robot 1 can take. I have denoted the path that robot 1 can take in the pink color. So for I equal to 0, this will be one path. For pivot column I equal to 1, this will be second path. For pivot column I equal to 3, this will be third path, and all the way up till n. And for each path, we calculate the sum of points remaining on the top row, that is top sum, and points remaining in the bottom row, that is bottom sum. The points that robot 2 can collect will be maximum of these two sums. And our goal is to minimize this maximum value. Therefore, for each part taken by robot 1, we determine the maximum points robot 2 can collect and find the path that minimizes its value. The time complexity of this approach will be O of n square, where n is number of columns in the grid. This is because robot 1 has n paths, one for each pivot column. And for each pivot column, we need to calculate the sums of the remaining points on the top and bottom row, which takes O of n time. So because of this, the overall time complexity is O of n square. And now the question is, can we do better? And the answer is yes. The bottleneck of the naive approach comes from repeatedly summing up the elements for top sum and bottom sum for each pivot column I. This is where prefix-sum can help us. For bottom sum, we can accumulate the sum as we move the pivot column from I equal to 0 to n minus 1. For example, for I equal to 0, bottom sum will be 0. When I becomes 1, then bottom sum will be sum of the first element in the bottom row. When I becomes 2, bottom sum will be sum of first two elements, and so on. Similarly, for top sum, we can pre-compute the total sum of the top row. And as we increase the value of pivot column I, we simply subtract the values as we move the pivot from left to right. Again, for example, for I equal to 0, top sum will be sum of the top elements minus the first element. For I equal to 1, top sum will be sum of the elements in the top row minus sum of first two elements, and so on. With this approach, calculating bottom sum and top sum now takes O of 1 time, reducing the overall time complexity to O of n. The space complexity will also be O of 1 because we don't need to store these prefix or cumulative sums in a separate array. We can compute them on the fly and use them in each iteration. Now let's see this in action. Now suppose this is the given grid, then sum of the top row will be equal to 15. That will contribute to top sum, and bottom sum will be initially equal to 0. Now robot 1 will start with the pivot column I equal to 0. So that means it will go with this path. We have to subtract this from the top sum. So our top sum becomes 14 and bottom sum is 0. Now as robot 1 takes this path, robot 2 can either pick up 14 points from the top right section or 0 points from the bottom left section, and it will try to maximize its points. So it will pick up 14 points. Then the pivot column I becomes 1. So the robot path will be like this. And now the top sum will become 14 minus 5, that is 9. And bottom sum will be 0 plus 5, that is 5. So now again robot 2 will try to maximize its points. So it will pick up maximum of 9 or 5, that is 9 in this case for this path. And for this problem, we have to minimize number of points robot 2 can collect. So we will take minimum of 14 or 9, and that will be 9 in this case. Then I becomes 2. So this is how the robot path will be. And the top sum now becomes 9 minus 5, that is 4. And bottom sum now becomes 5 plus 5, that is 10. So again robot 2 will try to maximize its points. So between 10 and 4 it will choose 10. And for this solution we want to minimize number of points robot 2 can take. So we will take minimum between 9 and 10. So the minimum number of points for robot 2 will be 9. And finally we come to I equal to 3. So the robot path will be like this. So now top sum will be 4 minus 4, that is 0. And bottom sum will be 10 plus new element 1. So it becomes 11. And again we will pick up the maximum of top sum and bottom sum, which is 11. And compare it with the minimum value we have seen so far, that is 9. So the minimum number of points stays 9. And that will be our answer. So now let's jump into the code part. First let's calculate top sum, which will be sum of total points in the top row. For that, either we can run the loop on the first row of the grid and sum up all the elements, or we can convert the first row of this 2D grid to integer stream using arrays.stream and convert it to long stream using asLongStream and sum up all the elements in the stream. Similarly, let's initialize bottom sum equal to 0. This will accumulate points for robot 2 in the bottom left section of the grid. Let's also initialize answer to very large value like long.max value, which will keep track of the minimum possible maximum points that robot 2 can collect. Now let's iterate through the columns of the grid and simulate the possible paths robot 1 can take. For that, first let's decrease the top sum by the points at the current column. This simulates robot 1 collecting points from the top row up to the current column. Now let's calculate the maximum points robot 2 can collect, which is maximum of top sum and bottom sum, and update the answer to the minimum possible value between the current answer and points collected by robot 2 for the current iteration. Let's also add current element in the bottom row to the bottom sum. This simulates robot 2 collecting points on the bottom row as robot 1 moves forward. This will be used in the next iteration. And once we are done with the simulation, we will return our answer. Now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.